Hello everyone, and thank you for watching this video. My name is Tanico Jackson-Martinez, Marketing Manager at Loop AI Labs, author of Cognitive Computing. Want it? Gotta have it, but what is it? Today we're going to talk about cognitive computing for enterprise digital transformation. In this session, we will walk through the current status and relevance for the adoption of cognitive computing, the difference between artificial intelligence and cognitive computing, and how to go about preparing for and implementing your cognitively enabled applications and solutions. Let's dive in. The call to action is now universal. You must adopt cognitive computing for your organization to survive. You must operationalize all of the data at your disposal, not just the 10% of structured data currently used by your analytics. Most of us understand that repetitive knowledge work, which is still primarily performed by people, is increasingly being automated by cognitive computing, but difficult questions remain. How do I transform my organization to this new reality? And what does it mean for our workforce? The answers to these questions are not obvious. The addition of a digital workforce doesn't typically replace human workers with robots. In fact, it augments their abilities, freeing their brains to focus on more creative solutions. Deloitte surveyed 250 executives in 2017 to understand the drivers for their AI adoption. They found that 51% listed enhanced features, performance, and functions of their products, 36% listed an increase in worker creativity, and 36% sought optimization in internal business operations after implementing AI and cognitive computing systems to their organizations. The improved efficiency is not just about cost savings or improved products. It is also becoming an essential component for economic growth. For many countries like Italy and Japan, for example, aging populations and worker shortages will produce negative economic growth unless automation can help fill the gap. With worldwide spending on cognitive computing and AI systems increasing 59.3% since 2016, it is apparent that this is a trend that is here to stay. The initial results are in, and the benefits of cognitive computing and automation are clear. But how does one choose the best solution for their enterprise in an ecosystem where every legacy system provider is offering their own AI add-on? Next, we will break through the haze to help you get your enterprise's digital transformation underway. Though both names are often used interchangeably, the underlying technology and end goals for AI and cognitive computing differ. AI, or artificial intelligence, learns from data and attempts to make the optimal decisions based on that data. Cognitive computing includes this function, but the critical difference is the additional goal to emulate the human thought process and produce similar results. To do this, cognitive computing draws from a variety of scientific disciplines to produce human-like understanding and behavior, including AI, machine learning, deep learning, psychology, and natural language processing. These ingredients are essential to achieve the transformative digital intelligence. Uses for these technologies vary. AI can help you change the song on your current playlist with just your voice, pick the most optimized navigation route in traffic, or highlight customers to follow up with. Cognitive computing can also help with these types of tasks, but has the capacity for stronger use cases, such as routing customer service calls or upselling services to clients based on their habits and preferences, and many other repetitive tasks and workflows. For enterprises, both technologies can increase the efficiency of employees and the organization. Given the choice, cognitive computing is a smarter investment for its deeper understanding and wider range for cognitively enabled applications. Its ability to augment performance rather than simply replace leads to a more natural adoption path. There are few players in the cognitive computing space, but the difference in approaches sets each apart. When selecting providers, you must take into account a few defining characteristics. Is learning supervised or unsupervised? And is the solution deployed in the cloud or on-premise? Just like humans, machines need to start by learning from the data that is relevant to the actions and decisions in the environment. There are two main approaches to how machines learn the domain of the enterprise, either supervised or unsupervised. The supervised learning approach uses labeled data and industry-specific models to build out its intelligence. Unsupervised learning does not require this expensive labeling process, enabling it to use all data, both structured and unstructured or dark data, to build unique models specific to only that enterprise. Unsupervised cognitive computing, therefore, can apply to a greater number of use cases, since it is not limited to cases where explicit human intervention or guidance is available to interpret and customize its understanding. Let's say, for instance, you're an insurance company looking for a solution to digitally transform your customer support back office. With a supervised learning method, all of the available data for the model must be labeled and added to a generic industry model that has been tailored for your specific use. A team of data scientists would manually label the data and add to or delete it from the industry model from which all of their customers or your competitors start. This approach relies heavily on human involvement to not only manually label all data, but also to customize the one-size-fits-most model to be specific enough for that enterprise's specific use. With an unsupervised learning method, all of the available data can be leveraged by the machine without human involvement. The model that is created is as unique as the data within it, exclusive to that enterprise alone. This allows for enterprises to utilize their unique workflows and best practices as training data to be automatically learned and understood by the machine. For use cases involving natural language, some unsupervised cognitive computing methods can understand any language with no translation, pre-programming, or uploading of dictionaries and ontologies. It can be robust to misspellings and human text errors. In fact, being exposed to messier data improves the machine's overall understanding. Just like training human employees, the machine self-learns by observation, learning your product names, company lingo and jargon, best practices and workflows that then become the knowledge foundation for your new cognitively enabled applications. When new data becomes available, the model automatically updates to ensure that the most recent and relevant information is incorporated. It is important to consider your preferred deployment method for your cognitive solutions. The most common offering from top players in the market are cloud-based. Very few providers offer on-premise solutions. Depending on your industry, cloud-based solutions may offer the benefits that you're looking for, but often fail to meet the compliance and security specifications that on-premise deployments provide. On-premise solutions are behind your firewall and reside within your enterprise's data center. Since the data never leaves the enterprise site, you can rest assured that your data remains secure. This is a huge point of interest for compliance-heavy industries like banking, financial services, and insurance. When it comes to implementing your digital transformation, it is tempting to buckle up and shoot for the moon when launching your first cognitively enabled applications. However, this is not usually the optimal path for success. Like human evolution, you have to walk before you can run, and this cliche is especially applicable to the transformation of your organization with respect to cognitive computing. Starting with large-scale moonshot projects often fail because they forget about the humans that they are designed to help. They fail to factor in and allow time for change management, adoption, and overall resistance. With new technology, there is a natural fear that this shiny new technology will make your professional contributions obsolete. This phenomenon can lead to employees dragging their feet when it comes to prepping for the arrival of their new cognitive systems, rather than pushing for success. Successful enterprises launch their applications one at a time, starting with high-impact but smaller projects. This allows for the simultaneous transformation of both your application and your current staff, who get to experience the productivity boost of software robots with the smallest possible disruption to their working world. It helps middle management adjust to new ways of planning and executing on cognitive computing projects, which lack clear-cut, known in advance specifications of integrating more straightforward IT systems. Mapping out the project plan or cognitive roadmap allows for transparency and innovation within the enterprise. C-level decision makers can be open with their staff and give them a clear view of the modernization on the horizon. From an innovation standpoint, once an enterprise launches its first projects and proves to itself that the benefits cover the cost of investment, then the creative abilities of the stakeholders are unlocked. That's all for today. Thank you for joining us.